are right triangles. If right angles, then right triangles. Remember, if has to be what was stated before, and then is happening right now. We also have OT is congruent to OT because of the reflective POC. And then triangle NOT is congruent to triangle HOT. What's our reasoning? Right triangles, hypotenuse leg. NT and HT were the legs. The right triangles was the R, and the OTs were the hypotenuse. So it wasn't in order of RHL, but they were all part in there. So let's look at what we have here. OG is perpendicular to DF. Now be careful when that happens. That does not automatically mean that it bisects the side. It just means that it forms 90 degrees. And if you have 90 degrees, you have a couple different things that can happen. You can talk about how those angles are right angles, which make them congruent, or you can talk about how those become right angles, which make right triangles. If you have right triangles, then you're going to use RHL. But we might not have enough information for the H and the L for you to do that. Let's find out what else we know. DOG is congruent to FOG. So it looks like this segment also bisects that top angle. So what else would we need to know? It looks like we're going to say that our angles are right angles, which make them congruent. So now we have two A's and the S that is in between, the reflexive side. So OG is perpendicular to DF. And angle DOG is congruent to angle FOG. That's all part of the given. Now, if you're perpendicular, then you know that angle OGD, angle OGF are right angles. If perpendicular lines, then right angles. And then we can say that angle OGD is congruent to angle OGF. If right angles, then congruent angles. Then what do we need to talk about? The reflexive property. Reflexive POC. And then of course we end with what we're trying to prove. And what's our reasoning for that? We get one of our 5 ways. Which is the correct one for the information we have in our picture? Angle, side, angle. Good job. One last one to go. We know we have a square. So if you have a square, one thing we're going to learn about a square is that all the sides are equal in length. And we also have 4 right angles. That is true about every square. Now, if we're going to prove these 2 triangles congruent, I might as well use side, side, side. You could use side, angle, side. You could use RHL. You have many different options that we could use here. but I think I'm going to use a reflexive property, and we're going to say that we have a pair of sides that match, another pair of sides that match, and a third pair of sides that match. So EFGH is a square. So that was part of our given. So I'm going to say that EH is congruent to GH, and that EF is congruent to GF. If a square, because that's what we have earlier, then congruent sides. Then we're going to talk about how HF is congruent to HF. Reflexive POC. And then we, of course, have our triangles that are congruent using side, side, side congruence. Let's take a quick look at the back. These are our answers, and it looks like for question number 10 they did the same type of thing. Just thought about that. So you can also go over your answers on the back and see if anything differed. Good luck.